Check, check. Okay, so welcome. I think we need to go a bit higher. Wow, this does not want to go higher. Welcome. Uh, so as you may know, I do these videos every week. I'm trying my best for them to come out better each week. There isn't much I can do right now. We're shooting off of my iPhone. I'm using a lens to make it seem wider, bigger. That really helps. Shooting against an empty wall and my bookshelf here. So hoping for the best. Dealing with natural lighting. So I can only shoot kind of in the afternoon. But we're good. We're here. And that's what's important. So let's start. So as always, in these videos, I start off with a little snippet of what's to come in order to save you time. In these videos, I always talk about my week and what I learned, but in the beginning, I'm going to give you a little snippet of what I actually learned, so you can skip this video if it doesn't interest you, or watch the whole thing if it does. Now, this week we did chapter 7 and 8 in the Think Stats book. I also worked on Cat Academy. I did scatter plots and bivariate statistics. So it has to do with like covariance and the relationship between two variables. Think Stats chapter 7 was also on scatter plots and a couple of transformations with those. And chapter 8 was on estimation. So we're dealing with bias statistics and best way to guess or estimate what a sample mean could be for, the whole population. So that was kind of it for the small rundown. Now for the rest of the video, I'm going to talk a little bit more about each thing in depth. Let me start off with the Khan Academy. So Khan Academy, I don't know if this happened by accident or if I did it on purpose, but it just seemed to line up nicely with what I was learning. So with Khan Academy, I'm learning the basics, high school level statistics, but it's a good refresher, and I was able to learn do a good refresher on stats right before I went into deep exploratory data analysis on a couple of real life data sets. So I was able to structure scatter plots and the relationship between variables and p-values and covariance, and do little exercises on Khan Academy. And then later on during the day, I would do chapter 7 on the Think Stats book, which was on scatter plots and was teaching me all about how to make them using Python and pandas. So that was really interesting and cool how that lined up. I might try to do that for next week, actually. And then also in chapter 7, I also learned about p-values, which I never knew were called Pearson values. I always knew p-values, and I had a good refresher from Cat Academy, like I said, but here in the book we learned it's called Pearson Values, and we learned about how he made it up, the whole history behind it, and how to use that to find the relationship between two variables, right? X and Y. And we use a data set on the weight and height of a population. As you may know already, we can infer that the taller you are, the heavier you are. And that, the data set did prove that, but you won't always get data that you can infer something like that. It just so happens that, we are humans, so we know how this shit works. Now, after we worked on Pearson Values, we learned all about how they might not be the best for anything that's not linear. So they're very good for showing linear relationships in the graph. So if you see a line with slope, with positive slope, and a lot of dots kind of following that line, you kind of expect that that's going to be a positive p-value, and it's going to be a little bit related. But if you see a lot of dots scattered all across the plot, then you have probably a Pearson value of 0. But that doesn't mean that they're not correlated. It might not be linear. So that's why we moved on and we learned about the Spearmint value, which is a tool used by statisticians when the p-value might not be the best fit. So we have maybe a non-linear relationship with our data set, and you can kind of use this, that's why you use the scatter plot first. You graph it first to see if it's linear or non-linear, so that can help you choose which of these values to calculate. And then we learned all about the Spearmint value and how to calculate it, usually for nonlinear relationships. And then we moved on to using maybe a log transformation sometimes. We might even be able to transform, let's say, the weight into a log and see if maybe then we can get a p-value that best fits the graph or the data set, really. And that was kind of chapter 7. It ended with a little note, probably which you all may know, that correlation does not imply causation, and that's something that's been said in stats very frequently, but in this chapter we kind of went over that. So after we find out that a data set, for example, has an x and y variables that are related, we now know that A could cause B, or B could cause A, or maybe that some other thing is causing both of them to move together. But we do not know really yet. We don't really know the relationship behind them. We can infer. Later on, we're going to do, I think, regression in another chapter that might talk a little bit more about that. Can't wait to learn that. But for right now, kind of left us with, correlation does not mean causation. So it kind of ended the chapter there. Then we moved on to chapter 8. Now, chapter 8 was a little bit confusing, but it was on estimation, kind of seeing if, the basic stats that we usually use, sort of, summary stats like mean, variance, standard deviation, and all those things can be biased sometimes, depending on whether the data set is big or small, whether it's a sample or whether it's a whole population. And so right now we're kind of just going over all the math that is checking and basically proving to us that some may be good, some may be bad, and why we get different values for example, a mean and a sample mean. So that would be, a mean would be a mu, the Greek letter m, and then you would have the x bar for a sample mean. And so, we're playing with that and, estimating that and seeing if it's a biased, not a biased statistic or not. So it's biased if after a very long time, or at least it's unbiased after a lot of estimations, you get closer and closer to 0. So for something like variance, if you have a small sample size, the variance is actually lower than it should be. So that's, one of the things I learned. Okay, and I already went over Khan Academy, which was just scatter plots and p-values and things like that. So awesome. This week I learned that I should try to see if I can do the Khan Academy before the Think Stats, like instead of just going through the curriculum that they have, maybe just skip ahead to see if I can relate it to the chapter, because it was a really good refresher on scatter plots and p-values before I went in to do the EDA, which is the exploratory data analysis. And on my free time I was doing a little bit of research on COVID data sets, trying to get one to maybe do my own exploratory analysis. In the book, we're doing exploratory analysis on birth rates, right? And pregnancies and fertility rates, things like that. And doing something like COVID, which we're currently in a pandemic, would be really cool because it would be more recent. So it was just, an idea to use a COVID data set that was more recent, and just do kind of my own exercises. And yep, that's the week. For next week, chapter 9 and chapter 10, a little bit of Khan Academy, and see where that gets us. What I'm going to do after this book, like I said, I am interested in doing my own exploratory data analysis, but I think I need a little bit more structure. I might do an online Coursera course or maybe another book on Python. So thanks for joining me on the journey, and I'll see you next time.